Hi everyone, welcome to another S3 Human Sciences class. As you know, we've already transitioned to geography. So today, after talking about the structure of the Earth, plate tectonics, our task for today is to discuss earthquakes. So what are they? What happens when there's an earthquake? How do you measure earthquakes? What are the effects of earthquakes? Okay, so this is all part of our considerations of geography. By the way, I don't know if you've been following the news, but in sometime in late March, there was an earthquake in Croatia. So, for instance, you can see the effects of that earthquake or those earthquakes in Croatia in this photo. This photo is not mine. I got it from the internet from Al Jazeera, but you can see that the earthquake caused some destruction here. Okay, so that's what we're going to talk about today. But first, the first question is, what are earthquakes? So earthquakes are, tremors or shaking vibrations in the crust. Okay, remember we talked about the different layers of the earth. So the crust is made up of different plates, different pieces of land, you might say, and then these move, remember? So sometimes because of the movement, the movements of these plates, that creates a lot of pressure so that that pressure or energy has to be released. Okay, so the causes are the collision of plates. They bang against each other. They hit each other, or they're moving they're crashing into each other, or uh, there could be plates that are sliding past each other. They could be moving in different directions, but they're so close that they're brushing against each other, and that causes a lot of tension, pressure, and energy that has to be released. And when that energy is released, you have an earthquake. Remember, we already introduced the idea of the fault. The fault, that's kind of crack. That's kind of discontinuity in the crust. So in a piece of rock, for instance. So there's pressure that's built up along the fault line. And when that pressure or energy is released, earthquakes happen. We already gave this example before, as you can see here on the west coast of the continental United States. You have two plates, basically two plates sliding past each other. So we're talking about the state of California here. So as you can see, this long red line, that's the San Andreas Fault. Here you have the city of San Francisco. So you see that this city is situated along the fault line. So you can imagine that there are actually plenty of earthquakes that happen in San Francisco. Not all of them, of course, are felt by people, but earthquakes are likely to happen here in this area because this area is where two plates, meet and slide past each other. Now, let's learn some terminology. So, when an earthquake happens, that happens in at the focus. So this, imagine that this is a piece of rock, this is a piece of the crust, okay? And the focus is the point beneath the surface. So that's the surface. That's where you stand or you walk. So that's, let's say, the road or or the ground. But in the rock, where that point where the energy is released, that's called the focus. Okay, this is a fault scrap. That means that one part of the crust of this rock is elevated. becomes higher than the other, because you can see here that this piece of rock basically splits. Okay, and one part of it just moved up, so that's a fault scarp, sorry. So we already know what the fault is, we already know what the focus is. So this is another illustration to help us understand what happens when there's an earthquake. So this is from the BBC website. That is the focus. That's where the energy is released. On the surface itself, right above the focus, this point is called the epicenter. Okay, so the tremors, the shakings, the vibrations are strongest here. So destruction is massive here in this area, and then the energy, the force, and the destruction, at least in principle, these things are reduced as you move farther away from the epicenter. Okay. Now, aftershocks, it's possible that, once an earthquake happens, because it releases energy, and energy travels, you know, and reaches other pieces of rock, other parts of the crust, and that energy could have effects on that piece of rock, and that means that smaller earthquakes or vibrations could happen after the main one. So those smaller ones that come after the main earthquake, you call those aftershocks. Okay, I'm gonna skip that. Now, um, how do we know these things? We know these things because there are people who are called seismologists. So these are experts, people who studied earthquakes. They studied geography for a long time, so they understand what happens, how to detect earthquakes, how to measure them, how to measure their energy, what to do, etc. So, how do you measure an earthquake? You use a seismometer. It's also called a seismograph. So, the seismograph, that's the instrument that you use in order to measure the vibrations, the energy that is released by the earthquake. Now that energy, that force of the earthquake is called a magnitude. So we usually talk about the magnitude of an earthquake, how powerful it was. Usually we use the Richter scale, so we say that an earthquake is, let's say, 1, has a magnitude of 1. That could be, that means that it's 1 out of 10. So the Richter scale is a kind of way of measuring how powerful an earthquake is. This was developed in the 1930s. The numbers, 1 to 10, they are algorithmic. That means that, for instance, number 2, if you say an earthquake has a magnitude of 2 on the Richter scale, that means that 2 is 10 times more powerful than 1. Okay? Practically speaking, this is a Richter scale. Okay? This is seismograph. Okay? This measures the power, the magnitude of an earthquake. And here you have a description of the Richter scale. So what happens? So if an earthquake has a magnitude of between 0 and about 2, that's an earthquake that you would barely feel. You wouldn't even notice it. And many earthquakes have this magnitude. Now, if you're talking about something like 5, a magnitude of 5, then you would have the effects of, something like the earthquake in Croatia. You would have some damage to buildings, to houses. So that would be something like this. But if you have something like, as you can see here, 7 or 8, that's really, we're talking about serious damage, to buildings, to houses, to roads, to bridges. Okay? Another way of understanding the magnitude scale or the Richter scale, which gives us an idea of how powerful an earthquake is. So you can see there, if you're talking about nine, an eight or a nine, that's almost total destruction in the area where the earthquake happened. And if you have an earthquake, a very powerful one, you would have a lot of aftershocks, smaller earthquakes that happen and then happen after, if you're talking about land. But if you're talking about, oceans, earthquakes can cause tsunamis, tidal waves. Okay. Now, these are the effects of earthquakes. This is also from the BBC. Short-term social impact, for instance, you can get killed, you can get injured, your home might be destroyed, transportation is disrupted, etc. Maybe water pipes are damaged as well. Economic impact, you know, businesses and shops that might be damaged or destroyed. It can be very difficult for transportation to continue. There might be, you know, we might have experienced trouble with our mobile phone connection, etc. Environmental impact. So the built landscape, we're talking about man-made things like buildings, okay, may be destroyed. There could be fires because of leaks, gas leaks, explosions. If you're talking about more mountainous areas, then there could be landslides and tsunamis can happen and can hit coastal places. Okay, those places that are near the sea or the ocean. Long-term impacts. So, for instance, there can be the spread of disease. You might have to move people. Some people might have to stay in a refugee camp. Uh, Long-term economic impact. It might be very expensive to recover from an earthquake. Okay, there's a lot of money and income lost, and then also long-term environmental impacts. We're talking about the loss of natural and human landmarks. So that could be a mountain, for instance. Uh, that could be important human landmarks like buildings or monuments, etc. So that could be destroyed by an earthquake. Now, just a couple of pieces of trivia. So fewer injuries and deaths are likely if an earthquake happens at night. Why is that? Because people are in bed and there are fewer people outside. Poorer countries experience more damage. And I think the answer to this is more obvious. It's because if you're a poor country, then it's likely that the buildings that you have in your country are not earthquake proof. So they're more susceptible to collapse, to being brought down because of an earthquake. So I hope that's clear. That's our discussion about earthquakes. Don't forget to complete the quiz that's linked to this discussion. I'll see you in the next class.